Bullshit, I can't hear you. Sound off like you got a pair.
It's a war. It's a war. There can be no mistake about it. It's a war.
Bullshit, I can't hear you. Sound off like you got a pair.
All right. Damn it. The streaming box rebooted. And it always it does that, and I forgot to go reset the microphone. Every time the system power cycles, it does that. All right. What I was saying earlier is, what's up, Gumby? What's up, Jesse? What's up, Samantha? Everybody else in chat that I mentioned before the stream started, what's up? I hope y'all are having a fantastic Sunday today. I had a really chill one. It was nice because I didn't have to run around like a madman today. I just got to do things at a normal human pace. That was lovely. That was a quite appreciated change of pace. Freaking microphone. That's really the only bug with the streaming computer. I don't know why. It's just for some reason the USB mic, it completely forgets about it and it undoes the OBS setting every time it power cycles. It power cycled last night because it was applying updates. Like, damn it. All right. So what I was saying though is this actually just came across my feed a little bit ago. And even though I'm not using Claude Code for this particular coding project, I still thought it was kind of interesting. So I wanted to take a look at it and see what it's doing real fast. Maybe draw some ideas for it. So the repo is called Claudeception. And basically says every time you start an AI agent, it starts from 0 and you spend an hour debugging some obscure error. The agent figures it out. The session ends next time you hit the same issue, another hour debugging. So this skill fixes that issue. When Claude Code discovers something non-obvious, like a debugging technique, a workaround, or some project specific pattern, it saves that knowledge to a new skill. Next time a similar problem comes up, the skill gets loaded automatically. And actually, I ran into something very similar to this when I was working on Ghostwriter last week, where when it was rebuilding the front end, it kept trying to run it directly. It kept trying to run the rebuild directly with NPM on the host when it should have been running it inside the Docker container. And so little things like that. But very cool. I'm going to tinker around with this. I'm not going to dig down deep into it. I think if you're wanting to learn more about some of Claude's inner workings, this might be a fun project to look at because this is using something called hooks. And so there's event lifecycle hooks inside of Claude Code. And one of them is like, hey, every time the user submits a prompt, and it's going to run this script in here. So that's a really neat idea. I like the idea of it. So I'm going to tinker around with it later. I just wanted to share that with everybody real fast. In fact, I'm going to star that one. Boop. Actually, hold on. What do I have here? Let me see. Let's make a new list here. Let's call this Claude Code Goodies. There we go. All right, so that one, there's now a list for Claude Code Goodies in there. All right, let's go take a look here. So, what else did I have going on today? Not too much. Oh, good news also. So yesterday I told y'all I spent several hours rebuilding the engine for Agent Zero's four-wheeler. Went over to go try and kickstart it today. Wouldn't kickstart. Did a little bit of tinkering with it. Finally got it to start up after, because we had to do like a rebuild of the head and the cylinder. So after we got that all cleaned up, it was a little bit rough to start. It was trying. It was trying real hard. Finally got it kind of stable. And then I shut off the fuel. I let it run out the gas in the carburetor, kicked it back on a little bit later, and it started up first kick. I was like, yes. So, excellent. The rebuild worked. Oh, thank you for that, Gumby, by the way. I just saw that over on the Kickin' Green site. All right, let's see. So this was something that one of my buddies at work clued me into. I hadn't heard about deep agents. I think I had seen it, but I hadn't really dug into it. And deep agents, which is part of the LangChain LangGraph ecosystem, he said it's kind of like, think of LangChain's approach to something like a Claude Code style agent. So let's take a look at this. Let's see. Deep Agents is a standalone library for building agents that can tackle complex multi-step tasks. Built on LangGraph, inspired by applications like Claude Code, Deep Research, and Manus, Deep Agents come with planning capabilities, file systems for context management and the ability to spawn sub-agents. So very cool. And let's see, they even have suggestions here. So when to use deep agents. When you want to handle complex multi-step tasks that require planning and decomposition, managing large amounts of context through file system tools, delegating work to specialized sub-agents for context isolation, and persistent memory across conversations and threads. All right, cute. Very cool. The sending stuff over to like delegate to sub-agents for context isolation, not really such a big deal for us because we're not using the message history as the context. So quick background here. Whenever you've got a language model and you're talking with it, right? What you have is you have a block of what's called your context. And it only can be so much size in there. And so every prompt will go into the context here. So our prompts, that goes into the context. Any messages that the LLM returns, all those will go into the context. Any user messages will go into the context here. And this also includes like any thinking steps, right? So if the language model is doing thinking where it's like, hey, this is what we're kind of thinking about, all that goes into here. Eventually this window fills up. Once it fills up, you just can't cram anything more into it. It's like you've exhausted the buffer. So if you are running certain agents inside here, everything that they do is going to start filling up this context window also. So what they're talking about is, one thing you could do is you could actually have an agent over here with its own context window handling various little tasks. So let's say that you have one particular message over here that says, oh, this is the information I need it to do. You could kick this over to the agent's context window, execute it, let it do its thing with its own prompts and everything, and then finally just the digest or whatever the pertinent piece of information is can be brought back over to here. So rather than having this entire context window, you just have this one little nugget is what gets transferred back and forth. Not such a big deal for us because we're letting those agents do that, but we're not using all these messages as our context window. We're doing a lot of context engineering in this project. So whenever we make these calls, we let them be very fine-tuned. Robo, popping shells. What's up, brother? Happy Sunday, man. Robo has popped 3 shells. My man. How hard would it be to implement? I don't know. That's why I wanted to read up on it, because I think this might be an interesting choice for the PostX agent over here. So I don't know if perhaps the PostX agent will just be its own deep agent. I'm not sure. And that's what we're going to figure out. Like, I thought maybe perhaps this might be a deep agent, but it could be that, hey, the entire PostX agent, we're going to use deep agent for it. And then when we come over here, we're going to have maybe the initial access exploit promoter. I'll come up with a name for this. But maybe this will just be a deep agent, or this will be like a specialty agent that gets spawned off the deep agent. I don't know. That's why I wanted to read on it and see how it's going. Awesome, Robo. Dude, we're supposed to have... Agent Zero is supposed to have his first cross-country race this weekend. So a week from yesterday, basically. So I'll let y'all know if we're going to have a Saturday stream coming up, because it depends on the weather. If it gets real nasty, it's just too easy for us to get the truck stuck out there. I don't have a big honking off-road truck. So if it gets too nasty, we just can't make it out there, because we're never going to be able to get home. We're going to be stuck out in the wilderness. So I will let y'all know what the score is and if we're going to have a Saturday stream or not. I'll have an answer come Friday. Let's see. All right, so for simpler cases, you consider using LangChain's create agent or build custom LangGraph workflows. So this really is its own standalone thing. Let's see. So what do we have for planning and decomposition? Deep Agent has built-in write to-dos tool to enable agents to break down complex tasks into discrete steps, track progress, and adapt plans for new information. Okay. For context management, we can use file system tools like list, read files, write files, edit files. Allows the agent to offload large context to memory, preventing context window overflow and enabling work with a variable length tool. Okay. Now what I hear, sub-agent spawning. So there's a built-in task tool which enables agents to spawn specialized sub-agents for context isolation, and then long-term memory, which extends the agents with persistent memory across threads using LangGraph's store. I guess it's its own proprietary database, or not proprietary, but so they've got some kind of database implemented in here. Agents can save and retrieve information from previous conversations. Oh, is that so, Mr. Bond? I'll be interested to see how that works. So Deep Agent is built on top of LangGraph, LangChain, and LangSmith, which LangSmith really isn't part of the execution. It is in our case, but it's not something you're actually going to be using day to day as you're running through this. LangSmith is for observability, evals, all the stuff we're doing like in here. This is LangSmith. This right here, and this stuff over here. This is technically like the LangGraph studio. This is technically LangSmith, whatever. They're pretty much like one and the same. What the kiddo think about the branch education videos? I don't think I showed them to him yet. We've been pretty busy. Maybe I'll show them to him tomorrow. Hold on, what were the branch? Link me those again, Gubby, so I can try to save a copy of it and actually remember to do that. Let me look at quick start here. So how do we get started with this? Prereqs. Before you begin, you actually have to make sure you got an API key for a model provider like Anthropic or OpenAI. We've got that. Let's see. Install dependencies. Actually, you know what? I was going to do something real quick. Hang on. Let me drop into OPSEC mode real fast because I want to go check something over on... I want to check how much I've got left for Anthropic tokens. Oh, geez. So we did burn quite a bit of tokens last night because we had, I think I started with 25. And yeah, so January 3rd, I put $25 in here. And then now we're down to like $17.50. Oops. Where's the usage in here? Somewhere in here, it shows us what the usage is. Here we go. This should tell us how much we used during last night's stream debugging the exploit agent. There we go. We used a grand total of 1.4 million tokens. Well, technically last night. It's saying the 18th, but that was really yesterday. I don't think I used any there. Oh, wait, hold on. Was this API usage? HackBot. Here we go. Yeah, we used 1.4 million tokens yesterday. Yep. That's funny. Oh, you whispered to me? Okay, cool. Thanks, man. So we might have to go set up a Tavali search key in here. So Tavali, by the way, you probably don't have to do this, but it'd be probably beneficial to do this. We'll see. But Tavali is essentially like a search engine for AI agents. It's designed and optimized for that purpose. And I haven't quite wanted to give HackBot access to something like a search engine yet, because I want to think of a way that I can restrict it to where it can't go cheat and look up answers to the problems. So let me look at that again real quick. Oh, yes, it was that channel. Yeah, I definitely need to show that to him. Absolutely. That was the one, it has like really great explanations on like how microchips work and microprocessors. It was really cool. All right, so let me see what we're doing here. So we set up our Tavali client. We define internet search. Oh, that's it? Okay. So we take in a query, max results, a topic, and then include raw content, false. All right. So that was step 3. Basically, they're setting up a search tool to use here. And then step 3 is create the deep agent. So we give it research instructions. So basically a prompt in here. System prompt is our research instructions, which is cool because it's just taking a multi-line prompt in here, which is handy. And then we give it the tools, which is funny because here it's just passing in this function. Typically, that's not how something like LangGraph and LangChain work. Maybe it's different with create agents and whenever you're actually importing this from deep agents, as opposed to something like LangGraph or LangChain. Because in those, you either have to use a tool decorator, or you've got to give it something like a doc string in here that tells it like what you're going to be doing. In here, they're saying, hey, you've got access to that internet search. That's about it. So let's read through the prompt here, because we need to understand how it was structured for understanding like what this is going to do. It says you're an expert researcher. Your job is to conduct thorough research and then write a polished report. You have access to an internet search tool for the primary means of gathering information, which is internet search. Use this to run an internet search for a given query. You can specify the maximum of results, the returns, the topic, and whether raw content should be included. This seems so... I don't want to say jank, but a little bit. It feels like there's something missing in here. It seems a little too cut and dry. So what happens? So the deep agent will automatically plan its approach, conduct the research with the internet search, manage context using write file and read file to offload large search results. It'll spawn a sub-agent to delegate complex tasks that it needs to. Okay. Interesting. So what's our next step in here? It's going to be customization. Let me see how we can customize this. It breaks down to everything at the microchip level to understand for all ages. That's cool. I gusta. Let's see here. So what they've got is whenever you do create deep agent, it's going to have some kind of core config, which is going to have a model, a system prompt, and a list of tools. And we have some features like what backend to use, sub-agents and interrupts, and then all that will be customized into the customized agent. By default, it's going to use Claude Sonnet, so you can customize the model by passing it a different string. Oh, so that's interesting here because they're saying like that's so wild though. Oh, you can also pass it a LangChain model object. Let me see if I was missing something real quick. Hang on, let me come back over here. No, so this didn't have any options. It was just, hey, this is how you do it. But also, if we can pass it a LangChain model object, that's great because in here, instead of doing like chat Olama, we can just pass it the LLM model that we're going to have it use. Sick. All right, so for the system prompt, we're going to have this. The deep agent comes with the built-in system prompt inspired by Claude Code system prompt. The default system prompt contains detailed instructions for using built-in planning tools, file system tools, and sub-agents. Each deep agent is tailored to use to a use case that should include a custom system prompt specific to that use case. All right. Maybe we'll see if we can go dig out the system prompt and take a look at it and then maybe customize that one for it. So in addition to custom tools, you can and you have the built-in tools for planning and file system management. So in this case, here they added they added this. Oh, so here's the doc string. Hold on, did I just miss it last time? Oh yeah, there it is. Okay. Okay, easy peasy. Let's take a look at the next thing. What about agent harnesses in here? So we think of the deep agents as an agent harness. It's a simple core tool calling loop as other managed agentic frameworks, but with built-in tool capabilities. So our deep agent can do isolated agent for sub work, get a final result. Can I blow this out a little bit? Okay, nothing happens from that. Final result just funnels back over. This is what I was talking about earlier in here. You can think of this sub-agent as like a modified little version of this one that just runs on its own, and then those final, basically, output unit gets kicked back up to the primary agent. State and file system in store for the storage backend. I'm curious about this. So for file system access, the harness provides 6 tools. We have list contents, read, write, edit, glob, find files matching a pattern. Oh, okay, cool. And then we have grep. Good old grep. Large tool result eviction. Oh, okay. So the file system middleware automatically evicts a large tool result to the file system when they exceed a token threshold, preventing the context window from being saturated. Ooh, I like that. That's pretty cool. And I've seen this happen before too. When I was working with Claude Code, a lot of times I'd run a tool, it would kick back just an absolute butt ton of info, and then it's saturating the context window. I like that idea. So this will monitor the tool calls for a default size result, typically 20,000 tokens, configurable for these other things. When exceeded, it writes the result using the configured backend and replaces the tool result with a truncated preview of the file reference, and the file reference. Got it. What about this? Pluggable storage backends. So we can do a state backend, which is ephemeral in-memory storage. Files live in the agent's state, checkpointed in the conversation, and persist within a thread, but not across threads. Useful for temporary working files. Or we can kick something over to the file system. Read and write to the actual disk. Supports virtual mode, which is sandboxed to a root directory and integrates with system tools. And then what else do we have here? A store backend. Persistent cross-conversation storage. Uses LangGraph's base store for durability. I haven't actually messed with LangGraph's base store in here. Let's see. And then also, what's the composite backend? Route different paths to different backends. Oh, okay. So for example, slash could go to the state backend. Memories could go to the store backend. Ooh, handy. I like that. Because there might be some stuff that, hey, you would just want to stick it in the state because it's only going to be useful now, but it's going to be huge and you don't want to throw the entire thing into the context. But there could be things like, hey, this is a critical piece of information. We want to save this for long-term memory. And so we put that into the store or the file system. Now, what about for task delegation? Yeah, delicious chicken. First off, killer username. Second off, welcome in. Happy Sunday. And yeah, that's the way I look at it too. It's like, hey, this would be very helpful for short and long-term memory. Get down. Get down, Peaches. Peaches like, I heard you talking excitedly. It must have been about me. That's my dog, by the way. My little Peach. All right, so what about task delegation to sub-agents? You get context isolation, parallel execution, specialization, and token efficiency. Let's see. So the main agent, so the main agent has a task tool. When it's invoked, it creates a fresh agent instance within its with its own context window. It executes autonomously until completed, returns a single final report to the main agent. Sub-agents are stateless and can't send back multiple messages. Easy. So there is one kind of default sub-agent, but you can go customize that. Not a big deal. Let's see. So for example, you could have a code reviewer, web searcher, test runner. And actually, this is kind of what I was thinking of, is perhaps for the post-exploitation agent, we have PostX be a deep agent, and then we have these specialty loops that occur in here that explain kind of, that are basically these sub-agents. So we'd have a sub-agent for escalating an initial access exploit to a C2 interaction. Yeah. The token efficiency is got some big air quotes around it, Gumby. And actually, we'll probably burn through quite a few tokens doing this because these models tend to churn a lot. They'll run like a couple of commands. And so pretty much anytime also, you're talking about these file system tools here. When it runs any of these, by default, these go get kicked into the context as well. So once they're kicked into the context, they could be there. So that's really cool that it's got the automatic offload of if it's more than X thousand tokens, then kick it to disk instead. I like that idea. Yeah, tool result eviction. Let's see here. Yeah, so you can define specialized subagents with specific tools. I kind of want to tinker with this and try it out. And then we can also do conversation history summarization. I think this is their version of compacting here. Harness automatically compresses old conversation history when token usage becomes excessive. Triggers at 85% of the model's max input tokens from its model profile. Keeps 10% of the tokens as recent context. Falls back to 170,000 tokens or trigger in 6 messages kept if the model profile is unavailable. Older messages are summarized by the model. Which I think for us, since we're using Sonnet 4.5, I gotta remember what it is. Let's see. Context window. So they have an extended beta version, it looks like. But it looks like the primary context window is 200,000 tokens, which is still quite a lot. Ooh, interesting. Claude Sonnet 4 and 4.5 support a 1 million token context window. The extended context window allows you to process much larger documents and maintain longer conversations. Oh, that's in beta though. And also, one of the issues that you have whenever you have a larger context window, we were talking about this last night, is that you'll start getting these areas called blind spots. So once this context window starts to fill up, right? So let's say we got lots of nuggets of knowledge in the context window. Once it starts getting above, I think 50% technically, but really I think it starts getting impactful when you're above 65%, is you start getting blind spots where this stuff here at the bottom gets weighted a lot more heavily. And so it might just forget that it had this piece of information right here. And not really forget about it, it's just going to overlook it. And it's not like one-to-one whenever it does it. It does it kind of haphazardly. So you could, in theory, kill these blind spots by running this multiple times. But again, you're looking at a lot more token usage whenever you do that. So it's not cost effective. The more cost effective thing is just to manage your context really, really well. Which is everything that's been happening over in the other agents that we've done. So in Enum, Recon, and Exploit, that's how they all are. What? Do you need to go outside again? No, you don't need to go outside. You're just begging for attention. Hang on one sec. Come here, Peaches. Come here. Come here. Come here. Come here. Hey, come here. Come here. Here we go. All right. You want your camera time? Here we go. This is Peaches, by the way. She is a Boston Terrier, and she is an attention seeker. Definitely. Who's a good Peaches? Yes, you are. Little snub nose. Come here. All right, hop down. There. You got your camera time. Are you happy now? All right, let me see here. What else do we have here? Ooh, what is this? Dangling tool call repair. Harness fixes message history when tool calls are interrupted or canceled before retrieving results. So for example, agent requests a tool run X, tool call is interrupted by whatever. Agent sees tool call and AI message but no corresponding tool message. This creates an invalid message sequence. So the solution is, when it has a message with a tool call but no results, it creates a synthetic tool message response indicating the call was canceled. Cool, very handy. To-do list tracking. So this harness provides a write to-dos to the agents, which can be used to maintain a structured list of tasks. Now, what's cool also here is it automatically supports human in the loop, but I don't know how it necessarily works in here. Let's see. So the harness can pause agent execution at specific tool calls to allow human approval or modification. The feature is opted via interrupt on parameter. Well, we're going to turn that off for now. Maybe we'll enable it once I go build the UI, but that's a ways down the road. What else do we have in here? This is actually one that's really cool, and we'll probably try to make as much use of this as possible since we are using an Anthropic API. With prompt caching, if you're using the same prompt over and over and over again, you can basically cache that prompt on their API side, and it'll already be tokenized. So I think it cuts the cost by like, I want to say 50%. Let's see, what is that? Anthropic prompt caching. I want to say it. So how prompt caching works, by the way. So the system checks if the prompt is checks if a prompt prefix up to a specific cache breakpoint is already cached from a recent query. If found, it uses the cached version, reducing processing time and cost. Because you got to think, what's happening here with this is, let's clear all this stuff out. Get rid of you, get rid of you. Every time you send something over to the language model, right? So you send a block of text over to it. That text has to go through a tokenizer, right? So tokenizer, to where then it can now be sent over to the actual LLM in here. So what the prompt caching is doing is it's preparing everything that it's going to run against the LLM and reduce the tokenizer in here, if I understand it correctly. So it's taking some of the pre-compute and basically just taking this. So let's say this is text 1. What it's going to do is it's going to save cache 1 up here. And that cache now says, oh, hey, this matches what we already saw. Don't tokenize it. Just pull it from the cache up here. Ditto. Just like that. So it's especially useful for repetitive tasks with consistent instructions. Yeah, we see that. What's the price reduction in here? Let's see. So for example, let's look at Sonnet 4.5, because this is the one we're at right here. So if we're looking at Sonnet, 1 hour cache writes, let's see. So you actually have to pay a tiny bit more the first time you use it, but afterwards, cache hits and refreshes are much cheaper. See that? Claude 3.7. Poor Claude 3.7. We used it for a long time, but it also was acting really dumb, so I don't miss it that much. Yeah, double check me on the facts for that, because I have not used prompt caching because what we're doing isn't especially well. I guess it could have been handy for some of the testing we were doing last night where the prompts didn't change. It could have saved us a little bit of token usage, but it's fine. Let's see. Actually, so for Anthropic, Harness enables Anthropic's prompt caching feature to reduce redundant token processing. Caches portions of the prompt that repeat across turns, significantly reduces latency and cost along with system prompts. Automatically skipped for non-Anthropic models, which is fine. That is something that is purely dedicated to the Anthropic side. Let's see. So what do I have for backends? Let's see. So choose and configure file system backends for deep agents. So you can specify routes to different backends, implement virtual systems, and enforce policies on these. Let me zoom that out just a little bit. There we go. Wish I could move this. I hate this interface. I've seen it in one other place. Guy had it on his GitHub, and I was like, okay, I get what you're doing here, but this is just let me drag it and drop it. So for the pre-built file system backend, you can quickly use that. So default is, so the default is the state one. So the default file system backend for an agent is stored in the LangGraph state. Note that the file system only persists for a single thread. Got it. Local file system persistence, which is, you'd actually then go specify the backend here and what the root directory is, right about meow. And we have durable storage using the LangGraph store. What is the LangGraph store? Hang on. Because I haven't messed with that. Component within LangChain's LangGraph framework that enables persistent structured storage for AI agents supporting short-term and long-term memory across conversations. Let's see, so it's organized using namespaces and a key, flexible storage backends. Okay, so we could actually go through and set something like a Postgres database in here. What if we could just use SQLite, actually? Because that would be handy. don't necessarily need a Postgres database. Let's see. So when you configure with the index config, the stores support vector-based semantic searches for embeddings. Oh, nice. Okay. I don't think we're going to necessarily need that, but it's good to know it's there. Maybe we'll need that when we start working on CTFs that are multi-box systems, something like Game of Active Directory. Ooh, I can't wait to go start testing this against Game of Active Directory. Ooh, that'll be fun. Because right now it's living in like very basic Linux exploit land, right? Super basic. It'll be fun. Let's see. Durable store and then composite, where if ever by default memories are persistent, composite backend is maximally flexible. You can specify different routes in the file system to point towards different backends. Okay. So here's an example they've got here. So if you just create a deep agent, and then from here, oh, here we go. So what they're saying is when you create this, it's just saying, hey, we're going to make this with a lambda of a state backend called RT. Yeah, runtime state. Got it. So best for scratchpad of the agent to write intermediate results, automatic eviction of large tool outputs, which the agent can then read back in piece by piece. Now for the file system one, read-write files are under the configurable root directory. You can actually set a virtual mode to sandbox and normalize paths under the root directory. And use secure path resolution, preventing unsafe symlink traversal when possible. Nice. Nice. What else do we have in here? All right, enough about the backends. This is how we would route to different backends if we wanted to. I'll think about that. I don't know if necessarily that's how I want to particularly do it. I think for now, keeping everything in the runtime state is fine. Oh, that's cool. You could also add a policy hook. Ooh, do we have hooks? Like lifecycle hooks? Are you talking, could we cache the prompt locally and then recycle it, Gumby? Let's see here. What else do we have for subject? Don't know if there's anything else I need here. Actually, I want to look at these hook references in here. So, block writes and edits under specified prefixes. Oh, gotcha. These usually tend to be fairly brittle, though. There's been some research recently about bypassing this, I want to say, with Claude Code. I think. No. So no, we could not cache the prompting data locally because it has to be processed by the API. So we're sending the text, but all of this happens over on the API side, right here. So they're the ones that have to cache it. And I doubt they're going to let you download the cache and then re-upload it. I mean, that might be a neat feature, but if they're willing to let you get to this part, because if you think about it, unless they're doing something way different with how their language model implementation is, then this probably is the part where they're doing the caching is in the tokenizer, which is basically taking all the text, formatting it, and then converting it into integers to go through matrix multiplication over here on the language model. As that's happening, I doubt that they've gone through and they've pre-processed a couple of these. Maybe they have. I don't know. The guys at Anthropic are fairly smart. There are a lot of different things other than just the generative pre-trained transformers, which is what GPT stands for. So they could be using something different where, hey, the first couple of layers are specifically designed to process the prompt, and then that influences the later layers. They could potentially be doing that, but long story short, they would technically be leaking proprietary information, because then, think about this, you could just send text and tell it cache it, and then download the cache, and then reverse engineer the process of what went in versus what came out. You could do that quite a bit. I would really like it if you could do that, but don't think they're going to do it. It's how they make their money. That is how they make their money. No, it's not dumb. And it's a good question because you have to think about what's the data flow as it's going through the process. So that was a very valid question, but ultimately, no, I doubt they would ever implement that. All right, let's look at sub-agents here. So deep agent can create sub-agents to delegate work, and you can specify custom sub-agents in the sub-agents parameter. Sub-agents are useful for context quarantining, which we already talked about. Why use a sub-agent? If you have a multi-step task that would clutter the main agent's context, specialized domains that need custom instructions or tools. Ooh, I'm liking this idea here. Tasks requiring different model capabilities, and when you want to keep the main agent focused on high-level coordination. Ooh, I like this idea. Let's see, what do we have the configuration? You have name, description, system prompt, and tools, and base model. That's cool that we could also tell it, hey, go use a different model for executing this. That is pretty cool. For complex workflows, use the built-in LangGraph. Oh, hold on. Sub-agent. Dictionary-based. Oh. Now you're speaking my language. You can also use a compiled subgraph from LangGraph, which is essentially what we're doing with the special agents already. The special agents become compiled. They become compiled LangGraph graphs, and then they're exposed back, and then we just invoke on that graph. Ooh, daddy likes. Create your own AI that does it all, and you can save your money. Dude, I couldn't bootstrap the costs to go make my own AI. Because they spend... How much would that be? Let's see. How much did it cost to train Opus 4.5? So I know it's not public information. The API's pricing is known, yada, yada, yada. Okay, actually, I tell you what, let's do some better example. Let's do GPT. Let's just do GPT-2 from OpenAI. The exact cost to train GPT-2 is not open. OpenAI has not disclosed it. However, it confirmed that the training cost was $256 per hour using 256 Google Cloud TPU v3 cores. Based on this rate, estimates for the total cost range from $40,000 to $50,000. And so that was just GPT-2. For contrast, modern reimplementations of smaller GPT-2 models can now be trained in 90 minutes for around $20. And that's using 8 of the A100 GPUs from NVIDIA. Let's see. I'll tell you what, let's try another one. How much to train GPT OSS 120B? Let's see. So the training cost for GPT OSS 120B, which is just a wee baby compared to something like GPT-5 and Claude 4.5 and all those other ones, is estimated to be $4 million based on usage of NVIDIA H100 GPUs at approximately $2 per hour, right? So if it was $4 million and they're charging $2 million or $2 per hour, right? You're talking just a huge amount of computing time. You're talking like 2 million CPU hours to do that. Let's take a look at that. So if they wanted to train that in a month, right? Because let's just do some numbers here. So they got 4 million, right? And it's $2 per hour. So we're at 2 million hours. So if we wanted to do that in a month, let's see. So there's roughly 30 days in a month. And so if we multiply that by 24, we get 720. So 2 million divided by 720 is 2,777 repeating. So they would have to have, let's see, what would they need to have? They'd have to have 2,700 NVIDIA GPUs running nonstop to train it in a month, right? And so they're talking about training this on an H100, right? So now let's do a little bit more fun stuff. Let's go to Vast AI. And let's see the pricing of an H100 right now. Let's see, H100. There's two different ones in here. And it ranges from $1.87 to $1.56, right? And that is, I believe, per hour. Yeah, price per hour, right? So you're talking, it took roughly, and this was estimated at $2 million, right? So anyway, I don't even have to do the math because we already had it right there. At $2 an hour, it'd be like $4 million, right? Still, a lot. So yeah, I'm not about to go try and hit some VC folks up for money to go train my own AI when there's guys with literal galaxy brains out there doing that. Oh yeah, man. To say that they have spent billions of dollars training AI models is not an exaggeration. All right, so let's see here for using these sub agents. So in this, they just pass it internet search right here. What about if you're going to use a compiled subagent? How do we do this? So custom graph. In this case, they're using create agent. Here's the model, your specialized data analysis, yada, yada, yada. All right, so here's where they create a custom from create agent from LangChain. Compiled subagent. Oh, from deep agents. Okay. And the runnable is the custom graph. Okay, cool. Easy peasy, lemon squeezy. Not too bad. Not shabby. What didn't help with fixing? Dude, I need help fixing everything. But actually, right now, we're working on actually implementing some new stuff, finally. Hold on, did the stream settings still say fixing stuff? Okay, no, it didn't. All right, good. Hold on one sec. I do need to drop into OPSEC mode real quick and go fix something. I just noticed one of the stream monitors is offline. Let me double check this real fast. No, it's still on. I don't know why it says it's offline. All right, whatever. So let's see here. Yeah, so Jehovah, what we're doing right now is we're actually planning out. Let me show you all this. So real quick background for anybody who's just hopping in. This is our managing supervising agent called Stinger. And then we have these 4 primary agents, which are compiled LangGraph workflows. And we just wrapped up the basic version of the exploit agent. It's working really well. So now there's another one that's going to sit right about, yeah, that is going to be the post-exploitation agent. So the way this works is recon finds out what's there. Enumeration finds out how much is there. Actually, I should take that back. Recon kind of figures out what's available. Enum kind of says, okay, what kind of information could we gather from what's there? Exploit then takes this information and starts probing it to see, okay, can we get an initial access exploit, which is a very specific type of object that says, hey, we found a way to get RCE, and here's how you duplicate that effort. Bam. So once that is done, then that initial access exploit is going to be handed off to the post-ex agent. And one of its first jobs is going to be to elevate that system over to a full C2 connection. So we're going to be mostly playing around with Mythic tonight. We're thinking about this. We're spitballing it. I need to message Cody and see if he'll come back on the stream because he's a super guy and he's the guy who wrote Mythic. So he's been waiting for this too. I told him, I thought like a month ago I would have this all sorted out. Then we had to go on that little side quest to fix the state management stuff. Oh yeah, not sponsored by Jocko yet. Which one is this? Mango passion fruit. It's all right. It's not as good as Afterburner orange, but it's all right. So yeah, I'm really liking the idea of this being a deep agent here. I can't write. deep agent here. And then this one just being a sub agent. I'm liking this idea. And in fact, we probably might be able to even just reuse this and re-architect it and turn Recon and Enum and maybe even Exploit into specialized versions of it and Stinger be the deep agent. But I'm not going to worry about that right now. I like what I'm doing. I'm having fun with it. I'm just trying to think how I want to handle this post-exploitation stuff. Let me come back over here. What else do we have for this? So, streaming mode. When streaming trace information, agents' names are available as LC agent name and metadata. So when retrieving the tracing info, you can use this metadata to differentiate which agent the data came from. Oh, cool. Not so much a big deal necessarily for us. Actually, hold on. We would need this because here's where they actually talk about it. So as you prompt your deep agents, all agent runs executed by a sub-agent or a deep agent will have the agent name in their metadata. So in this case, the sub-agent will have the name research agent. And this is where they're showing it right here. Here we go. So that was the research agent that actually generated this. Ooh. Oh, though, it actually says it's the research agent right here, so I mean, okay. Let's see, what about the general purpose subagent? So in addition to any user-defined subagents, Deep Agent also has a general purpose subagent, which is always available, has the same system prompt as the main agent, has access to all the same tools, uses the same model unless you override it. And you could use that, again, when you want to do context isolation. So, for example, instead of the main agent taking 10 web searches and filling the context with the results, it can delegate that to a general purpose agent and task research quantum computing trends. Nice. And the sub-agent can perform all the searching and just return the summary information. Excellent. Hang on one sec. I'm going to blow my nose real fast. All right, there we go. Best practices. The main agent uses the description to decide which sub-agent to call, so be specific. Analyzes financial data to generate investment insights with confidence scores. Bad. Does finance stuff. Well, maybe it just does finance stuff. And then also make sure you have a detailed system prompt. Oh yeah. Oh yeah. Also, minimize toolset. Only give subagents the tools they need. This improves the focus and security. I mean, that's really something that a lot of people have been like, hey, why do you need X when you can do MCP and do this other stuff right now? It's like, well, a lot of people are realizing that when you throw every MCP server under the sun at your agent, you're polluting the context with a lot of tool calls. And once you have, and we went through a whole step of filtering those tool calls and whittling them down to make them specific in here. Bro, you know where this would be really handy? What did I want to have? I wanted to have something that we could use to pick out like the ideal tool. This might be the way to do that. The quartermaster. I wanted to have a quartermaster agent in here that we could say, here's what we're trying to achieve with the information we have. What tool would be ideal for that? Let the quartermaster go through and churn on it and look at something. Also, the quartermaster is going to have it should have two parts. One, telling it what tool to use. But two, if we don't have a good tool, to make one. Yeah, buddy. How do I say that? Ryuhawk. I'm going to go with that. Ryuhawk. Thanks for coming online, man. Welcome in. I hope you're having a fantastic Sunday. Yeah, the quartermaster was actually going to have a second option here because if you remember, pull this up. Our tooling server, let me get that up. Where is it? Number uno, right here. Our RoboPages server in here. All the tools are just defined as, YAML files with Docker containers. So all we have to do is we can go make a sub-agent to that says, hey, by the way, your job is to now go craft this and then test it, make sure it works, and get it all copacetic. Ooh, yes. Yes, 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 yes. Daddy likes. This sparks joy. I do like this also. Minimizing the tool set that we already talked about. Choosing a model by a task. So different models can excel at different things. So, for example, what were the other ones in here I was looking at? Hold on, let the page refresh here. So yeah, GLM 4.7 and Minimax M21. Also GPT 5.2 High. Let me go see how much that one costs. For curiosity's sake, let's go to Open Router. Let's go look at models in here. Search for GPT 5.2. And then X. Those are the ones we got in there?
Incoming transmission from Morano Gumby. That beard is looking great, Daddy Blaise.
Damn it. I wish I had never showed you solo leveling abridged. Now it's like, yes, Daddy. Ugh. What is so I don't actually use OpenAI very much. So he's talking about GPT 5.2 High. Highest compute tier configuration for OpenAI's GPT 5.2 family, specifically optimized for elite engineering and complex agentic workflows.
Incoming transmission from Morano Gumby. You know you love it.
I'm not going to say I hate it, but I wouldn't go so far as to say I love it. Let's see. Yeah, so only available through OpenAI's API. That's fine. So what is the X high in here? What are these guys saying? How'd they do it? The only model that can you can leave overnight to do large refactor, and it does it even after multiple context compacts. Ooh, maybe I need to go. Maybe I've been sleeping on that one too much. I need to go check it out. What this fellow was saying was using it specifically in charge of reviewing and planning. Let me see, because I wanted to see what they were. Let me see if I can find the API cost. Because I'm looking at, I see GPT 5.2 Pro, but I'm surprised I don't see anything marked as X high on here. I don't know if that's a different compute tier of just running GPT 5.2. Let me see. 400K context window. I closed it. Damn it. We'll go back. So they have X high in here? Okay, so what do they say? So in our GPT 5.2 thinking is available today. Let's see. I don't understand the sentence. Developers can now set the reasoning parameter in 5.2 Pro, and both 5.2 Pro and 5.2 Thinking now support the new fifth reasoning effort of X high. Oh, I guess that's a quantifier you could set in there, like saying, hey, this is how much thinking I want you to do. GPT 5.2 is priced at $1.7 million, $1.75 per million tokens for input and 14 per million tokens of output. 90% discount on cached inputs. Interesting. Yeah, that's actually a pretty good pricing here. So hold on, let's go back over here. So if we look at 5.2 Pro, what's our overview price in here? Providers. Basically, OpenAI should be like the only provider. But what's... What the hell? That ain't right. Maybe it's not 5.2 Pro in here. Hold on. 5.2 Codex. What about just a GPT 5.2? What was the price on this one? Okay, so here's GPT here. So this one is $1.75 and 14 per million tokens. I don't know why Pro is like, just like, bang! This one's number 9 in programming. Hold on. I'm curious to see who has number 1 in programming. Google's number 1 in programming? For which model? Yeah. Well, I mean, it's not that wild, though, because if you think about it, what was the Quad 4.5 API pricing? It's not that wild because what we're using right now, Sonnet 4.5. No, go back. That's not what I wanted. I think this is the one I wanted. Here we go. So right now, Sonnet 4.5, which is right here, it's $15 per million output tokens. And it's 3 million per input token in here. That's part of the reason why, because of the extra reasoning output that I have HackBot return, and I have the language model return for doing that, that's part of the reason why we burned so much in tokens, because as it was going through there, we have it spit out a lot of extra information about that. So we have a lot of tokens that are being returned for every time it has to update the exploit task array. It's got to put out a lot for that. And then the next thing after that is it has to spit out, what is that? After that, it's got to spit out all the information for like the reasoning steps. So we get kind of chunky traces in here. It's like if we go look at it from last night, right? He just claps this down real fast right here. So this one run where it just went way off into left field, it burned 655,000 tokens for this one. Yeah. So, a chunk in here. So yeah, I think we did burn quite a bit. Let's see. So from a day ago, yeah, we had several in here that were like over 100,000. So believing that I burned 1.4 million, especially with this 655,000 one where it just went absolutely nutso. Yeah, I believe it. Highly, highly believable. And you would think that's bad. Look at Opus. Opus is $25 per million output tokens. So yeah, it's almost twice as expensive as Sonnet. So chunky. But that's actually why I was looking at this right here. Let me look at rankings. Rankings by token usage, by market share. Google's number 1 in market share. What about categories? Interesting. Now, actually, it's come down quite a bit. So Grok CodeFast 1, it started up here and it's been trending down a bit. It looks like... Which one is this? I'm trying to see what these ones are. Opus 4.5. So Opus 4.5 has been expanding quite a bit. And then what's the green one? Or the purple one. Which one's the purple one? GLM 4.7? No? Darker purple. Other. Is that it? Other by unknown. But yeah, actually, I've tested Opus when I was doing some work, and it actually seems to be doing a pretty good job for just like hands-off Ralph Wigguming some code. Let's see, what about for programming? Number 1 is Gemini 2.5 Pro? Really? Huh. The next one that's most popular from that is, and then Sonnet 4.5. Interesting that it's gone down kind of in usage there. I wonder how much Grok Code Fast 1 is. Let's see. Oh, dude, Grok Code Fast 1 is hella cheap. 20 cents and $1.50. So not bad. Anyway, this little exploration into the various models is because I wanted to see kind of what they were doing in here. Let me look at GLM 4.7. This was another one that was recommended. Fairly dirt cheap compared to these other ones. Let's see. Features two key areas. Enhanced programming capabilities and more stable multi-step reasoning execution. All right, now what was the other one? Minimax M21. Let's see, this is optimized for coding, agentic workflows, and modern application development. Okay. Hey, Fizzy, thanks for coming online. Welcome in, and I hope you're having a fantastic, stupendous, amazing Sunday. Yeah, so what I'm looking at here, though, is because we'll have the ability to specify different models, and because we can actually go set the... I have to think about this, like how I'm going to set this one up, because they're using this in a little bit weird way. But what we'll do is I eventually have been planning to switch HackBot to using OpenRouter instead of the direct Anthropic API gateway, which we could still do, actually. We could tell it, hey, we're already going to have multiple LLMs defined in there. So, for example, if we come over to the config file in here, where's utils, configuration, let me bring this over. Yeah. Here we go. So in the configuration file, what we do is we have several models kind of defined, and then we expose that as an object over here. There was other stuff in here, but it kind of got deprecated and kicked out of there. So what we could do is take this, and we could have different language models in here. So we could have a default one, but we could also have like a thinking model. We could also have like a coding model. We could have all these different ones defined in here and let the agents go use those. Kiddo, what's up, brother? Yes. This is going to be fun. And I say that now until I have to actually go figure out how to use it all. Let me double check something real quick. Because I thought I loaded some tokens over into OpenRouter, but I got to double check. Let's see, credits. Yeah, I did. I loaded like 30 bucks in credits over there. So we can go check that out. So all we have to really do is to use OpenRouter with LangChain, because that's the one's making all of the language model calls. All we have to do is go through and basically make a wrapper around the OpenAI one. So we're not going to import one specifically, LangChain model for OpenRouter. We're going to import the OpenAI one, superclass it, and basically hard code in all the OpenRouter stuff. At some point, it's got to be cheaper to just to buy a DGX Sparks for under your desk. Oh, I wish, man. Well, let's think about it. Let's do a little bit more back of the envelope calculator, right? Let's say I spent $50 in tokens per day, right? So where would that get us? At that point, yeah, it might make more sense to do that. Now, one of the downsides is, yeah, you can run some chunky models on something like the DGX Sparks. The main thing that pissed me off about the DGX Sparks is the memory bandwidth. The memory bandwidth is absolute piss. It should have been so much better. Anyway, that aside, you can run larger models on them. You can easily run probably up to a 200 billion parameter quantized model on it, and it costs $4,000. So yeah, if we were doing something like that, it would totally. Now, for what I do here on the stream, I only do this on the weekend. So this is just like my Saturday and Sunday burn. I do have my own private Claude code that I use. It's Claude Pro, which is $20 a month. It's not bad. I've been actually enjoying the heck out of that. And then when I'm doing stuff for work, that all comes out of my work budget. I'm not dealing with anything on that side. So I'm not paying for those carbon tokens. That's what I'm gonna start calling them. Everybody was like, "Hey man, we gotta drive electric vehicles and not use plastics and all this other stuff. We're killing the environment." No, you know what's killing the environment? AI catgirl videos. That's what's killing the environment. I'm gonna start calling them carbon tokens. I mean, if you didn't know this, they're data centers to run AI systems are using so much power. They're actually talking about restarting the 3 Mile Island reactor. Now, don't get all bent out of shape about, oh my God, but 3 Mile Island wasn't safe. It actually, they did a pretty good job on that. What's his freaking name? Kyle something over on YouTube. He did a great video on like what actually happened over at 3 Mile Island and anything. But no, nuclear power is incredibly safe. And especially when you compare it to like how much power you get out of those things. Don't think of Chernobyl. That was like a 6 standard deviation event that happened over there. Leave it to the Russians to screw up something that should have been a perfectly safe operating reactor. TVA is going to get some private company to start up a reactor in Oak Ridge, Tennessee. I don't doubt it, man. I don't doubt it. And it takes so long to get a power plant online. Typically, it is, I think, 10 years. I don't remember if it's from the start of planning or for when groundbreaking happens to bring a reactor online to when it starts generating electricity for the grid. I think it was like 10 years. So even if they like really streamline that process and cut it in half, we're still talking 5 years before that comes up. Yeah. Nuclear power is way safer than coal. We have spicy rocks that make power. It is awesome. I need to go look at this. How we specify what subagent is going to go to which model is going to be interesting. Let's see. Return concise results. Instruct subagents to return summaries, not raw data. Do not include raw data, intermediate calculations, detailed tool outputs. Keep response under 300 words. Yeah, gotcha. What if this? Okay, cool. Common patterns. Multiple specialized subagents. So like we might have one that's a data collector, a data analyzer, and then a report writer. Excellent. Workflow. So like this case, the main agent would create the high-level plan, delegate data collection to the data collector, pass that to data analyzer, send the insights to report writer. And so if you wanted to keep these out of the context window, what you'd have is you would just have the data collector here. In this case, it's got database query, but you might also just give it access to like, hey, here is like file write, where it could go write this data that it gets to disk, and then data analyzer could say, okay, cool, now you can go read the data from disk and then go process it. Actually, what would this one do? Gather raw data from various sources, collect comprehensive data on a topic. Yeah. Let's see, subagent not being called. So main agent tries to do work itself instead of delegating it. Okay. So for example, good example would be research agent conducts in-depth research, used when detailed, yada, yada, yada. Bad example, helps with stuff. Well, yeah. I mean, that's like just saying if you have a bad prompt in there, it's going to be crappy. Solar's just free wireless fusion power. I love the idea of solar. I hate the idea of trying to cover beautiful arable farmland where food or animals could be raised with solar panels. And there was actually, so speaking of power, there was, what was that? Giant solar array in the desert that heats a tower. What was that one called? Let me see if I can find this guy. Yeah. So this giant solar array in here, the idea was all these mirrors were supposed to like reflect the sun's light in here and boil the crap out of a bunch of water and do this. However, a bunch of these mirrors, see how these mirrors are like all out of alignment right there? This thing didn't work worth a damn. The only reason this power plant generated power is because they were using natural gas. Yeah. They were actually using natural gas to go generate enough of the power in here. This was like an utter abysmal failure, and it never generated enough power. And it's stuff like this that I was like, oh, I like where you're going, but your execution leaves so much to be desired. I like the idea. Anyway, I'm not going to go off on solar power rants, what should be a good idea implemented poorly. Hang on one sec, guys. I got to get some water. I'll be right back. All right, I'm back. Guess who's back? Back again. Blaise is back. Tell a friend. No, seriously, tell a friend. Come hang out with us. And damn it, Gummy, I'm not pooping. Bunch of weirdos here. All right, let's see. For compact, okay, so hold on. We were looking at this real quick before I got sidetracked on solar. And you're right, Gubby. Solar is not good for baseline power, but hopefully it is good. I mean, it is good for like the daytime whenever you've got large amounts of, hopefully, sunshine shining and people are up using more electricity. Although part of the problem with we discovered in Texas. Oh, you made me tea. Thank you. Sock made me some tea. One of the problems we discovered in Texas is that every new building that's being built, every apartment complex is running on electric heaters because the builders were too lazy to run gas lines, even though we have an absolute metric ass ton of gas in Texas. We're a very gassy state. And so what happened during the snowpocalypse of, when was that, like 2021, 2022, somewhere around there, is that all the solar went offline because it was gray and overcast, and it got too cold, and so all the wind went offline. And then everybody is cranking their thermostats, and they're using electricity to do that. So it was very close to having a collapse of the Texas grid. Thank God that didn't happen, because doing a black start of a grid is a pain. And keep in mind, this is coming from a guy who's got solar panels on his house. Let's see. Yeah, solar is good for augmentation. It's not good for sole source generation. Let me see what else is here. Wrong subagent selected. All this is basically coming down to prompting. Let's see. Human in the loop. How do you configure the human in the loop here? I'm curious about this. See, here they're using the tool decorator. I guess because they're going to be using these with LangChain instead. This is what I was so curious about. It's like, in all the previous examples, they did not use the tool decorator from LangChain for this. Hold on. So where's delete files going to be used at? In the deep agent. So I'm confused here. The docs, I like LangChain, but sometimes they're not super clear about how things should be, and you actually really have to go RTFC. Yeah. Unless, Gumby, there was a way to have, like, unless battery technology or energy storage gets very, very good, then yeah, you'd have to have the solar panels being able to generate power 24/7, which you really can't because the Earth rotates. Tasty tea. All right. See, this is what I was talking about. With that tool decorator, what it does is it comes through and actually looks at this doc string and then looks at the inputs, and it prepares this and kind of formats it to make it a nice, easy to use language model call. And this is what I don't get. So in Deep Agent here, we have the tools defined, and then we have interrupts on those tools. But each of these, like for example, we go back to the quick start even. So in the quick start example, right? Internet search didn't have the tool decorator, but yet they're claiming that this would have still run. So I'm curious what they're doing differently. Why is the tool decorator included here and not in the other place? Let's see. Anyway, I'm curious how they're doing the human in the loop interrupts, because I might want to use this. So in this case, they're interrupting on delete, read, and send email, and which could be an approve or reject. And then decision types, approve, edit, or reject, handling interrupts. So when an interrupt is triggered, the agent pauses execution, returns control, checks for interrupts in the results, and handles them accordingly. So, for example, we have a config, we give it a thread with a thread ID, so it makes it a unique execution path, essentially. So if you had like multiple instances of this running, each instance would kind of be its own thread. It have its own thread ID in here. So if get result equals interrupt, or if, yeah, result get interrupt, extract the interrupt result, action request interrupts, review config. Okay, so this is all stuff. This is just doing it programmatically. It's not how you would actually handle it like in a user interface. Well, let's see. So when the agent calls multiple tools that require approval, all interrupts are batched together in a single interrupt. So you must provide decisions for each in order. Makes sense? You can also edit the tool arguments, sub-agent interrupts. This isn't something we're going to be using right now. I'm just bookmarking this for future information. All right. What about middleware in here? I'm not really so concerned about long-term memory. I don't know, maybe. Because, for example, there might be something I noticed from Daniel Miesler's personal AI infrastructure project is that what he does is he has hooks set up in Claude Code that are designed that, hey, once a task is done, it kind of looks at it and then creates a copy of what was done, puts it on disk. So that way, the next time it has to do that, it can reference it and then execute those same steps again. I think that's really cool, and it's a little bit of a double-edged sword. What he's trying to do is make what could be a probabilistic execution path more deterministic. I like the idea with that. I want to go play around with it. And Daniel Miessler is a hell of a smart guy. So I don't believe he'd put out something that was kind of janky. But also, I don't fully understand it, and I want to play with it and test it eventually. So what is this middleware here? So the deep agents are built with a modular middleware architecture, and they have access to a planning tool, file systems, and ability to spawn sub-agents. So each feature is implemented as a separate middleware. So when you create a deep agent, we automatically attach a to-do list middleware, a file system middleware, and a sub-agent middleware to the target agent. So the middleware is composable, and you can add as many or as few middleware to an agent as you need. You can add any middleware independently. So for example, on the to-do list, so if you use Claude Code recently, you'll notice how it writes out a to-do before tackling complex multi-part tasks. You also notice how it can adapt to and update this list on the fly as more information becomes available. So the to-do list middleware provides your agent with a tool specifically for updating the to-do list. So before and while it executes multi-part tasks, the agent is prompted to use the right to-dos tool to keep track of what it's doing to see what needs to be done. Let's see. So what did this say? It said before and while it executes that. Okay. To-do list middleware. Same thing with a file system middleware, so you could intercept on reads, writes, and edits. And you can also do short and long term. Okay. Cool. Awesome. Okay, I got an idea of how this is going to function. I want to try some stuff out now. Let's get out of Deep Agent. Let's go actually dig into Mythic real quick. Not that Mythic, this Mythic. Here we go. So this is the Jupyter notebook that comes with Mythic in here. So I'm logged out. Oh, what did I make my password? I think it was super password. No, password 1234. There we go. Super secure. So whenever this ships with Mythic, you can come over here and then come down to services. There's a Jupyter notebook right here. That's where you get to this interface. So Jupyter notebook has a bunch of examples that Cody put together that says, hey, this is how you do certain different things. So I think one of the things we want to do is, let's go take a look at payloads. So what are we going to have to do for this? Actually, I tell you what, let me go back over to, where is it? Here we go. Let's come back over to the code. Let's go pull up our to-do list. Right over, yeah. Here's our to-do. Let's see, I think we can go ahead and take this out. I'm just going to put an NA right there. I'm going to take this stuff out. We've already got this stuff done. Same thing with enum. Let's take that out and then exploit. Actually, this is not for exploit. This is for postex. So we already did that. Let's take that sucker out right there. And we did complete all of this. That was good. Boop. Okay. So for postex, let's think about let's look at the workflow ideas here. So we take a look at this. Workflows, and then let's say for our workflows ideas, let's do one here. Let's say, actually, let's take this back out. We'll just do it like this. Let's see. Yeah, we'll call that initial access exploit to C2, right there. So this is, so what we want to do is, first thing we want to do is we want to analyze the target. Analyze the target. Is it, find the OS and the, what else do we want to have here? Execution method, i.e. this will either be like maybe, so it could be like maybe we can run code, commands, web shell, whatever. We want to see what the execution method is for it. Then what we need to do is find an appropriate payload. Did I misspell? I did misspell appropriate, didn't I? Find appropriate payload. And then let's think about how I want to map those out. So let's see. So web shell, we'll go ahead and map that over to Arachne. Yeah, we're going to use the Arachne web shell for that. Let's see, for Windows plus commands. We would do that. I think we're going to do Apollo for that. In fact, we're just going to say for Windows, it's going to be Apollo. And then for Linux, we decided it was going to be what? What did I say for that? I think we said Poseidon. Yeah. Poseidon. So we use the Poseidon agent for that. Yes, yes. So once we've got all these kind of set up, and even from Arachne, we could even then, once we've got Arachne up and running, we could even then go and upgrade it to Poseidon, but so after we find that appropriate payload, then what we want to do is we're going to have to, let's see, we're going to get the payload. We need to get the payload variables, like what we need. So whatever we're going through this, we're going to make a list of like what variables we need to go put in the payload. IP address, URL, if we're going to obfuscate it, things like that. Hey, chicken, what's up, man? So, in fact, here, let's take a look at that real quick. So if we come back over to Mythic, and if we come here to payloads, generate new payload, we can choose the operating system right here. So let's say Windows, right?
Incoming transmission from Moreno Gumby. Did you have one for Mac and other ARM devices?
No, we're. I could go run Mac in the home server, but it's going to be running, I think, Tahoe. Older version of Mac, the last one I think that supported Intel architecture before they switched over to the M chips. So, for example, if we're looking at... Oh wait, is Arachne the only thing we've got on here? Oh, sure enough it is. Okay. Okay. Ooh, I'm gonna have to see which languages Arachne actually supports, because Arachne, I think, and it can definitely do PHP. I think it can do ASP. I think it can do jar or WAR files. But we'll have to think about this, because right here we only have Linux and Windows right here. So I tell you what, let's go ahead and set that up real quick. Let's go and get Apollo and Poseidon set up in here. Let's see. So let's do... I think this might show it. Let's see. Wow, that sounds like a lot. Hold on. He has the stars listed here? Nice. Nice. So he's already got... that's funny that Apollo has this. What Thanatos? Ooh, Thanatos could actually be another option, because this will actually run on Linux and Windows hosts. Let's go look at that one. What's our feature set on Thanatos here? So background job management, built-in SSH client. So connect to a machine and download or upload files between that machine and Mythic. Let's see. Spawn agents, SSH agent hijacking. Future additions. Okay, what commands do we have? Our basics. Cat cd copy download. Get environment, get privs. Job kill jobs. Actually, so one of the downsides is different commands I think are going to be available in this. Thanatos is able to work in Linux and Windows, right? So if we're working with Thanatos in those two different contexts, we have to keep track of that. Not such a big deal, but I think it's better to have an agent that is dedicated to a particular operating system. I have not messed with Thanatos yet, but it looks very interesting at first glance. Use SSH to execute commands, download or upload files, or grab directory listings. Ooh, fancy. Oh, that's cool. Spawn a Mythic agent on a remote host using SSH. Ooh, nice. Windows, actually, hold on. So Windows specific commands is PowerShell. What is get privs then in here? Oh, it just gets the privilege of the agent session. Got it. I was thinking of something like the get, basically like get system command that's on Meterpreter. That's what it made me think of. All right. Okay. I'm going to keep Thanatos on the back burner because I do like it. But let me go look at Poseidon right here. This one's for Linux and Mac. We're not going to be doing Mac, so we're going to be sticking over into there. So let me go get Poseidon. So this is how you go install these. So once you actually want to come and install these agents in here, you can actually just run this command. And if there's a particular branch you want to run of it, or if you've got a local copy, and say like you're making modifications to it, you want to test it, you can install from a folder. But installing from GitHub makes it really straightforward. Let me check, what branches do we even have in here? We have a Mythic 3.3. Hold on, which version of Mythic are we running? Let me double check. Yeah, we're running Mythic 3.3, so maybe we want to run the Mythic 3.3 branch. Probably not, because this says this branch is 144 commits behind master. Who did the last commit to master? Hold on. GitHub Actions bots? Hang on. Let me look at the commits here. Is Cody the one? Yeah, it's a feature. That's Cody. He's the one actually maintaining this. Okay. Got it. So we'll just use the master branch for this one. So let's go do that.
Incoming transmission from Marano Gumby. Can you link that agent chart that you were looking at?
I sure can, sir. Right, mirror. Drop that in for everybody. And for some reason, Kick is not working. So there, I just dropped it over for Kick as well. Let's see. Medusa is also another one. If we had a Python specific one that we wanted to use, we could do that. What is this one? I haven't seen this one. Karen MTC, C2 agent, fully pick. I think you meant to say pick compliant for Mythic with advanced evasion capabilities, .NET PowerShell, shellcode, BOF, memory executions, lateral movement, pivoting, and more. Ew, fancy. I need to go look at these, man. Let's see. Okay, but anyway, let's go grab Poseidon real quick. So what we're going to do is, here in Poseidon, we're going to grab a copy of the get command here. And then all we're going to do is we're going to go run the Mythic CLI. We're going to say install from GitHub, and we tell it what we want to go install. So, easy peasy, lemon squeezy. Let's see, I'm already in here, so let's do Mythic CLI. We'll have to run this with sudo. And what we'll do is install GitHub. And I'm going to take off the .get. I'm just going to tell it, go grab this one. Ta-da! There we go. So we just got to let this run, and then let me go pull up Apollo as well, because we're going to do the same with Apollo. In fact, I can just copy the URL here, and we'll be good. Copy link. So we'll give this a second to churn. Good old Mythic. I really like Mythic. We were using Cobalt Strike on my last penetration test, and oof. Not that it didn't work or anything, it's just Cobalt Strike was written... When was that released? Hold on. Cobalt Strike public release date. When was it released? Yeah, it was released in 2012, right? And it looks like it was made in 2012. That's all I'm going to say. It looks exactly like it was made in 2012. Then again, the big magic to Cobalt Strike has never been the operator interactions. It's always been the features of Beacon. That's really been always the shining star of it. Everything else has been ancillary. What's taking so long for like this last little bit to pull? Come on. I tell you, while that's doing that, let's go look at our list of items again real quick. So, yeah, we'll have to find a way, because actually, and it's not a bad deal. So what I was wanting to show you though is that there's different settings that we're going to do for these different payload types. So get our payload variables. And then after we get our payload variables, we're going to have to generate our payload. Then we're going to have, after we get the payload, we're going to have to find some way to get it on the host. So, transfer to the target, and then execute payload. Check for new callback. Test callback execution. So that's kind of what we're going to be looking at for where we're going to be going with this step through here. Really, I think I want to do it like this. We'll do... We do a little bit of formatting here. Actually, those can stay as bullet points right there. There we go. In fact, I think I can just do it like this, and it will auto format it. Screw it. I'll just do it myself. A little bit of markdown formatting. Stop. I bet that install of the container better be done by now. Hey, there we go. All right, so we'll run the same command again, but now we're going to drop in the Apollo URL for the GitHub repo. So Apollo is what we're going to use over for Windows, and then we're going to use Poseidon and Arachne for everything else. What was this? What was this issue? That was like right now. Let me look at something real quick. Where's our logs? That's odd. Let's run the status here. Let's check our mythic CLI status. Oh my god, yeah. Let's see. Okay, well, it says our Apollo, Arachne, and Poseidon containers are already up and running. Let's see if we can make something real quick. So if we use Linux, and then we change it to... Do I need to reload this page? That's suboptimal. What up? Let's see, Windows. I think I might have to restart those containers. Let's see. I think it's like service Apollo restart. I think that's the command. Or maybe it's container? I forget what the command is. Restart will restart all of Mythic, but I don't want to do that. I think it is... Services will list out all the services. Status stop. I gotta remember how to actually do that. 8 out of 10 beard. Dude, I wish. It feels like it's just been a concerted effort for basically 4 years to grow it out. Ever since my second son was born. He's 4 years old, and basically about the time he was born, I stopped shaving because work got insane. And then it kind of, and I used to keep like a really trim beard, and then it started growing a little bit more. And then when he was old enough to like get control of his hands, he reached up and he was like grabbing it and playing with it and giggling his little butt off. And I was like, all right, well now I can't cut it off. And so it's just been growing ever since then. I look so different than from my like wedding photos with my wife, where like I had hair and no beard, to where now I have no hair and all beard. Granted, that was 11 years ago that we got married. Damn, doesn't feel like 11 years, man. That's what I'm trying to remember what the command is, Gumby. Because once it's up and running, usually it's real good. I don't remember what it is. Backup, build, config. Restart says it restarts all of Mythic, but I don't want to restart all of Mythic. Yeah, that just restarts everything. That's all right, but Jesus, it's fine, man. Come and hang out and BS if you feel like it. We just have a good time in here. And if there's something you're curious about, feel free to ask. Everybody who has been watching for a long time knows I have absolutely zero issues going way off into left field to answer questions. What the heck was the command? This is driving me crazy. There should be a command in here to restart like one particular container, and I cannot remember what it is. I could just do a restart and like have it restart the whole thing. It should hot load in here, but this is, I think, a little bit of a known issue. This thing says it stops all of it. I'm gonna try it. I'm gonna try it with restart. All right, I need to go yell at Cody because this should have an option instead of just flags. We should be able to supply the particular container we want to restart. Because if you look at it, I ran it and it's like, okay, cool, we're gonna do Apollo in there. All right, great. So now if I come back up to here, let me reload this. So now if I choose Windows, now it's still not there. Okay, fine. You know what? Just restart the whole thing. Just restart it all. Do you know about digital sovereignty? I mean, I know about like sovereign citizens. I'm not familiar with necessarily with digital sovereignty. It's a term I'm not intimately familiar with. All right, let's see here. All right, now that it's restarted, I think we have to log back in when it does this. Do I need to log out? Hang on. I'm going to log out. I'm going to close this. I'm going to close the Jupyter Notebook too. Just close the whole thing out and let's restart it. All right. What was it? Password 1 2 3 4. There we go. Oh, it's so tiny. Zoom in. Generate new payload. Yeah, Linux is fine. There's got to be an error happening. I mean, because we did generate some errors in here, right? We got two things. Something about version 1.40 isn't supported. Max version is 1.4. Let me check the logs. I believe there was a log command. You could tell like which one you wanted to get logs from. Let's do that. Let's see. I think it's logs Apollo. Ooh, rip. Likely means your PyPy or Golang is out of date and should be updated. Please try again. All right, let's stop everything. Let's try updating Mythic. We'll get on the latest version. All right, update. Your Mythic version is up to date. Rip. Let me start it back up here. Well, apparently an update didn't work, Gumby. Which, this was a pretty fresh install, so I didn't think it was. I don't think so, because PyPy shouldn't be running on the OS, it should be running in the container. Let me check the logs for Apollo again. Let's see, this is using UTC time, but this is at the right time, because UTC time is, I'm at GMT -6, so yeah, this would be 4 in the morning. All right, what does this mean here? This might be a container issue in here. It might be I need to kick out this version of Apollo and use a different one. Let's go open the Apollo branch. Let's see. I mean, the Mythic 3.3 one is 190 commits behind master, so... Oh, so this is still set up for Mythic 3.2. Oh, damn. So digital sovereignty is basically building your nation in the digital world to claim sovereignty and legitimacy. Countries like Tuvalu, which is disappearing, is sort of doing it. And curious what you think about it. I've not heard about that topic, but Jesus. Send me a link on it. Like if you've got a good reference resource on it. Because I'm always curious on like what the effects of technology are on people. Obviously, I know what the effects of technology were on me from when I was younger. And now that I'm an adult, obviously. So yeah, if you've got a good link that is kind of explaining the core concept, shoot it over to me because I'd be very curious to read about that. I don't know if it's the version of PyPy that I'm using or the version of PyPy that the container is using. Let me check issues here. This is from 4 days ago. You do that yourself, dude. You do that yourself. Well, actually, what is his complaint here? Okay. Contains explicit identifying metadata. Well, yeah. This is a public agent. It's not supposed to be OPSEC safe, bro. Let me tell you, let me search inside here. PyPy. So what is the exact error we're getting? So the error we're getting is likely means your PyPy or Golang library is out of date and should be updated. Let me see where sync payload data is. Why is this not working? There we go. Let me go back to the code here real quick. So from what we learned during our agent dev stuff, this should all be over in payload type Apollo. Let's go look at the Docker file in here. So for this, he's using the Microsoft .NET SDK. All right. So if we look at the Mythic code in here, well, let me actually look at the init here real fast. So for the init, let's see, search path is going to be agent functions. Invalidate caches, nice. All right. These are all the commands in here. Yeah, this should be on the Mythic side. It's not in the agent code, is it? Yeah. Let me go look at this real quick. I'm trying to see where this might be busted because I don't want to downgrade to... Did I just completely break this? Reconnect. Let me just log back in. There we go. Yeah, so we're just constantly getting spammed with these in here. Lame. I'll have to ask Cody about that. Anyway, I'll tell you what, let's walk through this though. I'll figure this out later. I know it's an issue because I think all those agents are currently supporting Mythic 3, 2. And maybe we should actually, I'll tell you what, let's try something real quick. Let's go kick that out real fast. Let's see. Sudo Mythic CLI. Uninstall. Let's do uninstall Apollo. And I tell you what, let me go grab the, I'm going to grab the version from the Apollo 3.3 branch. Actually, we could run the same install command. We just tell it that we're going to run branch would be Mythic 3.3. Oh god, what was that? Well, it doesn't matter. Here we go. Mythic, I know you can't see it because it's behind me right there, but what I'm doing is I'm running Mythic 3.3 branch. Couldn't find the branch to clone. What? Oh, I guess it would help if I spelled Mythic right. There we go. So now it's going to clone that particular branch over to it. No, we're running Mythic 3.3, Gumby. So we want to pull... I'm going to try pulling the version of Apollo that is prototyped for 3.3. We'll see what happens. So now if we come back over here... I'm going to resolve all of these real quick. So one of these is still popping up. Oh, I don't know if that fixed it. Because, see, we're running Mythic 3.3. That's what I say you. So I don't think it's going to work. Yeah, it's still not showing up in here. All right, let me go stop those containers real quick. Let's go stop Apollo. And then we'll stop Poseidon as well. Poseidon. We'll stop him for now. And actually, when I get Cody to come on the live stream, I'll make him do live tech support. Anyway, let's go through this process right here. So for when we're generating Arachne, right, here's what we've got. We tell it, hey, what's the kill date? It automatically defaults to 1 year in the future, and what encryption type we're using for this. Then from here, if we had particular commands we wanted to hot load in, we could do that. No exit command. This one is a special case because this is a web shell. It doesn't actually have an exit command. Like we normally would have a process running on that system. We'd execute it, and then when that happened, we would say, okay, cool, now we're going to kill that process, we're going to exit out, it'll be done. This is a web shell, it doesn't work the same way. And then from here, we can do a particular web shell option, right? Say, we could give it the IP address. Let me see, what did I have in here? So this was a particular like IP address that we'd use for this here. In this case, we did hack it. And we did our DNS. Ooh, that's actually another general update I wanted to add to this. So, where's my to-dos? Server management, we still need to do this. There we go. DNS server, something to allow all Docker containers used for custom DNS entries. Yeah. So, this is something I need to go take a look at right meow. Because this is going to... What we could then do is we could say, okay, let's go specify like some creature comforts in here. And so our DNS would now be, instead of trying to get the IP address, we could just say hack.it and let it go for there. All right. Anyway, so after we went through and create this, it's going to look a little bit funny in here. I'm not going to go ahead and make it now, but because I don't have the box even up for tonight. But once this comes up, we come up to our callbacks here. Let's see, that's our profiles. Where's our active callbacks? Here we are. Active callbacks. You see that we have this one right here. This one's a little bit different because after we went through and we created it, we would get a new callback. See, this one says last check-in 8 months ago. Yeah, not really a thing we'd want. So what I'm going to do is, this one doesn't even exist. I'm going to hide this callback. After we go generate this, I tell it, F it, let's do it. Let me... where's it? Actions. I'm going to delete this one. Somewhere here, there's a delete option. Stop loading a new... No, where was it? I forget where that is in here. Oh, it's right there. It's the big... It's the big red icon. Here, I'll give you an example. So when I come over to payloads, right? And I come over and let's generate a new one. So we'll throw something junky in here. So we'll do Arachne. We'll let the default options be here. And then I'm just going to pick a random C2 profile. When this gets generated, we'll just call this Arachne test. Notice now, all of a sudden, we've got a new callback. It's on an unknown host with PID 0, even though we haven't executed this anywhere, right? If we go look at the callbacks, now we have this kind of pseudo callback right here, number 10. What this will do is we could run the check-in command, and it will go reach out to the URL we specified, which is where the PHP script would be living, and then we could go run it and let it do its thing in there. The first purely digital sovereign nation to exist in the metaverse. Ooh. I'm surprised I didn't hear about that. I want to say that that would have probably caught my attention. But thanks, Blaise. I'll check that out because I want to go take some time to read through it, just not at this exact moment. All right, let me clear these out. Resolve, get those off the plate. But anyway, yeah, so this is what would happen here is we had this guy spun up. So let's go take a look at the Jupyter notebook now, because what we'll need to do is we'll need to go through this payload generation process. So let's go to Services, Jupyter notebook. We have spun as Jupyter. Let's see what we have here. So we could list our callbacks. We've got that as an option. Custom queries. Delete tasking callbacks, file browser, files, miscellaneous. Payloads. Here we go. So from this payload example here, I'm trying to blow this up so it's a little bit more legible. So what we do is we come through and we could log in to Mythic. So we give it like what the username, the password is, server IP address. And so this is an example we could actually run on a different server as long as we could point over to it. Good luck hacking or whatever you do. Be good. I try to be good, man. Thanks for stopping in, Blaise, though. I hope you have a fantastic Sunday and a great rest of your week. All right. Okay, here we go. Here's how we would go through and we would create a payload, just like so. Boop. So this is very easy because we could systematize this and basically say, okay, cool, here's our placeholders, what we're going to do, and throw that in there and just make this a straight up Python function. Make it a tool. In fact, here's a perfect example. This one's for Poseidon, operating system Mac OS. So we'd have to go probably adjust this and test, make, make little adjustments to it. But yeah, this would be perfect. Unfortunately, we can't do it right now. Oh, great. And here's even downloading a payload, getting all the payloads, get all the command for the payload types. Nice. Nice.
Incoming transmission from Marano Gumby. Did you start the box, and if so, you might want to add time.
I did not start the box. I knew we weren't going to get to it tonight, and I wasn't planning on running anything on it. We could go try it on here. Now, one of the other cool things you can do that's not OPSEC safe, but we're operating in a CTF environment, it's not a big deal, is we can actually come over here and we can... Oh, where is that option in here? I think it's view config. Now that's the view build messages. Oh, it's over here. So this little eye icon right here, this tells us what the download URL would be. But if I take this and I copy, I don't want to open in default browser. I don't want to download that to my system and have it be flagged. All right, fine. We'll just copy this the hard way. So if I take this and copy it, I believe you have to be logged in to actually make that work. So here in this window, we're not logged in. Oh, no, it actually did download. Okay. Sick. I thought that had to be set up to where you had to do this, but you could also come over and do payload hosting right here. So we could tell it what C2 profile we were potentially using, what host path, and we could get alerts on when that file gets downloaded also. Let's see, Arachne test payload. Send alerts when it's downloaded. There we go. Yeah, I don't think it needs a C2 profile for this. Must select a running egress C2 profile. Ah, damn it. Okay. So we have to make a profile for that. So, oh, we don't even have like HTTP installed in here. Oh, rip. Okay, let's go get. Ooh. Dude, I freaking love Mythic. I tell you what, let me go spin up the box real quick, and what we'll do is we'll just do a manual hack on it, and then we'll upload this and try it out. Let's see. Yeah, I know the time expired. We'll start it up and we'll just tinker around with it real quick, too, and I'll show you how it works. So let's go ahead and start the machine up. All right, we'll give it a second here. We'll get the IP address, and then once it's up, what we'll do is we'll go upload that Iraq. We have to go regenerate it because we need to actually put in the IP address. Then we'll get it going. Do I use this for work? Yes. So whenever I'm operating at work, we usually use one of two C2s. We'll either use Cobalt Strike or we'll use Mythic. And given the option, I will typically default over to Mythic. Oh, I might have taken my bedtime pills too soon because they're already hitting. I took them whenever I went and took my bathroom break. Which was not really a bathroom break. It was really a water break. But it turned into kind of like an Omni break. Alright. Once this comes up, let me double check something real fast. Let's see. Alright, cool. We're already connected to... Let's go grab the IP address. We'll see if it comes up here. Okay, so it's not up just yet. The box is probably still booting up. Yeah, and also I was really tired, Jesse, from just today. I went to bed a little late last night, which is on par, and had to get up early for church this morning. So we were gonna try and take the kids riding this morning, but it was crazy cold. So I think we were gonna wait until, I don't know, 11:30 or noonish to go take the kids riding, but oof, it was just a little too chilly for the willy. Okay, there we go. So it's up now. That's all right. Let me open. Let's go like ultra hacker mode. We're gonna go. Now, what is it? Damn it, not you. Does this one not have incognito? I wanted ultra hacker mode, incognito. Oh, there it is. New incognito window. Okay, so let's go do this real quick. So what we'll do is go right there, and I think it was the... Was it admin? No, it was panel. Panel right here. Boom. So let's go ahead and do this again. So we'll come over here. I'm going to just delete this one out. We'll make a new one. Actually, hold on. I got to do this slightly. Actually, no, it doesn't matter. We can do it this way. So we'll go make a new payload. We can use Linux. Doesn't matter. Arachne. Don't worry about the commands. Okay, so here what we're going to do is we are going to use the web shell one in here. I'm going to copy the rootme connection, but I got to change this IP address right here. So that needs to change it. And also whatever we're going to call this. So I'm going to just call this arachne.php5. So we're going to go upload that file to it here after it gets generated. So we'll call this .php5. Generate payload. Boom. And now you'll see we have an additional callback over here. So this new one that's just been created. So let me hide this one. So this will be our active one here. So what we're going to do is we're going to download this guy. So first thing, let's go grab a copy of this file. We'll just leave that over in our downloads folder. And then what we'll do is we're going to just upload it. So we'll upload from, where's downloads? There we go. Downloads, Arachne PHP5, upload, boop, just like that. So now it says it's good. Doesn't show us where it is in here, but if we come over to the uploads directory, we'll see it in there. So there's Arachne PHP5. And so now if we come over to our callback right here, and we just tell it to check in. Boom. Now it's gone through and it's running. So this, notice how everything in here was blank until we actually told it, go check in, touch the server, give it a little bit of, you know, magic fingers, and then go through and run on it. So now all of a sudden the IP address, the host name, the user we're running on, all that information got gathered and brought back to us. So that command issued the C2 server to actually go out and touch that server and get all that data back. So now we can run pretty much whatever we want to. So like if we want to run like a shell command of pwd right here, boom, we've got it. It's 57 degrees in Arizona. It's actually not super cold right now. It's 42 here in Dallas.
Incoming transmission from Mariano Gumby. Can you do all that again? I was watching you.
All right, here, let me walk you through it again real quick. So for Arachne, this is a web shell, right? So let me come down here. Let me clear out some of this junk real fast. So let's take all that out. Yeah, go right there. Yeah. Take all that out. Okay, so you only really have two types of connections whenever you're working on a system, right? So you've got your attacker system here, and then you've got your victim system here. No, it's too late. You already asked. You already asked, Gumby. You're getting the lesson.
Incoming transmission from Mariano Gumby. I'm trolling. You don't have to.
It's too late. It's too late. You already asked. All right. So here, whenever you're running on your attacker system and your victim system right here, you have ones where the attacker system actually reaches out and connects to the victim. This is called a bind connection or a bind shell typically. And this also is what web shells do, right? Because what we've done is,
Can't hear you. Sound off like you got a pair.
Killa, you give me trust issues, bro. Anyway, so the bind system here is what web shells are using. So if we put a web shell on this system and it gets triggered when we visit a particular URL, right? Then every time we want to send a command, we're going to reach out to that URL, we're going to encode our command, we're going to send to it, and then it's going to execute inside the web server process. Now, let's say we had an executable that was running on that. So either like an exe or an elf file, elf, in here. What they would do is they would actually start listening on a port. So they're going to start listening on, let's say, I don't know, our good old favorite port of 4444, right? And then that just becomes an open TCP port that our attacking system knows that when we want to get command execution, we reach out and touch the server and we connect on that port. Bam, we get our shell. Option number two is we have the victim server after the binary runs, right? The exe or the ELF will take this and it will call back to us. And this is called a reverse shell. Reverse. So we have bind shells and we have reverse shells. The difference is just in the direction of connection. Bind shells, attacker talks to the victim system. Reverse shell, the victim system calls back home to us in here. And they have different benefits. Some people say, I only use reverse shells or I only use bind shells. Well, I know you're full of crap because they have different uses in different situations. So if I'm directly network adjacent to a system, I'm going to use a bind shell. If that system is nestled deep in, or like it's on the perimeter of their network, and I know it has easy, readily available internet access, I'm going to use a reverse shell. So they just exist in different situations. All right, so after we've gotten this, let's go look at something real quick. So when we generated the payload, we can sit here and we can view. Actually, I think we can see it over here. Somewhere in here, it'll actually, hold on, I think it's actually export. Yeah, export payload config. So we can export that and save it. Let me just go over to downloads. We'll save that right there. And unfortunately, the way I'm doing this here, it saves it to our local system, but it's not a problem. It's no matter. It's no matter. Let me see here. Hang on. I gotta turn on OPSEC mode because I don't know what the last thing I was doing in VS Code is. All right, good. My waifu image generator was not up. Great. There we go. All right. So here's what that JSON looked like after I brought it out. Let's blow this up. So this gives us all the information we need for like the C2 profile, right? Profile type is web shell. It's considered a peer-to-peer connection and all the C2 profile parameters. So this is the kind of information we want to take and go put into that Jupyter notebook right here. See that? C2 profiles? Boom. And then we're also going to look at the build parameters in here. So our build parameters, what kind of AES pre-shared key we're going to be using, what's the decryption, encryption key, yada, yada, yada. And then what commands are available. I don't think this really matters so much for the web shell in here. But those are the variables that we would populate into this. It actually tried to save it as .php Gumby, and I just told it to save it as PHP 5. So, because I already knew the trick. So what we'll need is, we'll need something that can connect over to Mythic. So then we'll have our Mythic instance. Let me try this actually. Hold on, what was the account we set up for? Let's go over to users here. We made a Stinger bot over here. Yeah, we did. Username Stinger. Let me try this real quick. So username Stinger. Password is going to be the super elite password 1234. And the server IP for this should be 127001. We'll try it. I doubt this is going to work because it's using Docker. That's why. Actually, it looks like it did okay. Just we got a warning on it. Interesting. Well, let's go try and fill in the data we had from VS Code into here. We'll just see if it actually works. So we're going to need the C2 profiles. Let's grab this. And I'm going to drop it in up right about Shamir. So we'll have to fill all this in. This is a horrible IDE. Okay, so C2 profile is going to be our web shell. Let's see. Actually, now that I look at this, I think this would have just worked just fine, actually. if we just take this out, boop, do like a so. We'll do it like this. It looking like a man. We'll comment that out for the sake of history. And actually, we'll just fill in all the relevant pieces of information here. So we have our build parameters, right? So where is our, this is our build parameters. So literally we just take this array right here. We do a little bit of copy. We do a little bit of pasta. Why does he keep wanting to indent? Let's go with it. What is this? I think it's build. Ah, screw it. I'm lazy. I don't want to type that much. And we just take that, put it like that, put it like that. Excellent. All right. Move that in a scope line like so. There we go. So here we can actually specify like the pre-shared key, the kill date, everything like that. And then what else do we need in here? Commands was also something we needed. I'm going to take that out. I'm going to move it down right about schmear. And then we'll go grab the commands as well. Even though I don't think we need the commands in here, we'll grab it anyway. So let's fix this up like about so. Move that in a scope line so it looks like this. And actually, I hate that idea. Let's take all this back. And we're going to just do it like so. There you go. Now it looks like a command. We'll save that. Oh, see, it trolled me because you weren't paying attention. You thought it did do it. I mean, you can tell it what extension to use. There's usually an option there. You can tell, hey, use this extension, use a different extension, anything like that. So now, what do I want to call this one? Oh, we got to change these two. Payload type. That's how I'm going to just delete all this out. You're going to go bye-bye like that. Let's see here. So payload type, we're going to change to good old Arachne. Boop. File name is going to be... Let's see. We'll call this Python test API. Now. .php. Why not? And then I don't think we need to specify the operating system because it doesn't really matter. Selected OS Linux. Okay, fine. We will set that to Linux, just like that. So now let's go run this and we'll see what it does. Oh, I'm an idiot. There we go. What is this error? Name true is not defined. Oh, did I? Maybe capital T? There we go. There we go. No errors, successful. And now we have the new UUID of the payload. So if we go look over in Mythic, we should see that new payload generated right there. Python test API.php. Let's go. Let me look at something real quick. So we got the UUID back from that, right? So there's our UUID for this. Everything in Mythic is basically UUID based. So if we look at this, I'm pretty sure that's the same one. Let me see. 25 fad. It's a fad. Nope, different. Okay, so that doesn't give us the download in here. Oh, but actually from here, what we can do is we could go download the payload from here. So if we take this, boop, and we drop that in there. Why'd you do that? Hold on, let me look at something real quick. So this one, actually, so the UUID for the payload is A072C. Let's go and get all payloads in here. Let's see. Print payloads. What is this returning? This is returning us a list in here. Oh, I hate this. Here's the UUID value right there. Evil2.php5. Actually, this should be, if it's down, if it's an array like that, it should be down here at the bottom. Here we go. There's Arachne PHP5, and then where's our UUID? I saw you in here somewhere. We have a whole bunch of UIDs in here. Hold on. ID4, here we go. I believe it's this one. Oh, it's so ugly. Hold on. I gotta remember how to pretty print Python. I'm always missing something. Let's see. Python pretty print JSON. What was that? I don't remember. There's a cheap and easy way to do it. That's if we import JSON, json.dumps. All right, let me do that real quick. Let's do. Yeah, let's do that. Run that, and then down here, let's do JSON dumps payload bytes. Oh no, this is the wrong. That is not the correct section. Hold on. Take that back out. Down here's where I want it. Let's go right about Schmear. You bastard. Change that to a 2. There we go. Ah, so much easier to read. All right, let's zoom down right about here. All right, here we go. This is our Arachne PHP 5. And then what we're looking for is, and you know what I think I really want to do is, I think I can just tell it, maybe give me the last element here. No, because it's going to convert it to a string. But I think I can do it right here. There we go. That should give us the run for Arachne PHP 5. And the one we're looking for is, this is the UUID it returned. That's what I want to double check. So it's 072C. Yeah, so I don't see that being referenced in here. That is the UUID of the payload config right here. 072C. But why don't I see that in here? Wait, am I looking at the wrong one? No. This is our Python test API PHP. Yeah. So it should be A072C. This gets us all of our payloads. And you notice how the list was longer than what we've actually got. It's because Mythic keeps track of all that stuff. And here it even shows you like, hey, which operator created this? Well, let me try this real quick. So using this UUID, I don't get why there's a difference here though. Why what it returned didn't match. me back this up.
Oh, because I'm a freaking idiot. Yeah, I'm a dummy.
When you execute this one, payload response is the return value of this, which has UUID 072C. And then it was referencing that variable, and I was just changing it. And it's like, what do you mean you can't find the key? It's because I'm a freaking moron. That's why. Hey, Bacon Rock, thanks for coming online. I hope you're having a fantastic Sunday, especially watching me flounder and fail with the very basic of Python, even though that's what I've been doing exclusively for the last year. All right, so there's basically our PHP web shell right here. Ta-da! So that's all good. All right, cool. So this will get us part of the way through that to-do list. Let me come back down. Yeah, okay. So yeah, we analyze the target, find the appropriate payload. I think what we might need to do is actually kind of restructure this a bit, where if it's Windows, let's come back here. So, for example, we could say web shell Arachne for this one. I'm going to do the same thing right here. So we'll need to do a little bit of fine tuning. Once I go bug Cody and I say, hey Cody, why Apollo no do? I didn't realize Cody was in the process of migrating to 3.3 from 3.2, so that's all right. This is fine. Everything is fine. But anyway, so once we can find a way to get the payload variables, in fact, let's go look at that. So what did we need for this? We go look at the Jupyter notebook again. What did we really need? We needed to know what the payload type was. We can get that really easy. We can generate the file name. Operating system. That one we'll have to double check. We'll want to make sure we know exactly where it is. Drewski, what's up, brother? I took my sleepy pills too early. They have hit hard. I'm gonna crash right after the stream's done. Let's double check something real quick. Let's go pull up one of the traces from the last time the exploit agent ran. Load latest, why not? All right, so here was the last successful execution of the exploit agent. And let's just look at something real quick. Let's look at what the state table looked like as we were getting started. And then let's go look at the host data on what we've got for it. So the host is running, it's running 22. It's running on 80. We have our various verdicts of like what happened to it. So we don't directly do an operating system check, but there should be enough information to infer like what it's running in here. Actually, if we look at like all the information on what was gathered from the various ports, right? We see it's running Ubuntu SSH, it's running Ubuntu version of Apache HTTPD. So yeah, we can infer this is going to be a Linux operating system. So that's no problem. From the information we're gathering, we should be able to kind of figure that out. So that's no problem. Figuring out if it's going to be Linux, that's great. A lot of this is going to be boilerplate. P2P is going to be true. Profile is always going to be web shell. And the C2 profile parameters, not really worried about modifying those. The URL we're going to need to generate, but let's go take a look here. So once we're done, let's come all the way to the end. Let's look at the input for the exploit agent. So we close this up. Right, so do we have initial access exploit? Oh, we don't, hold on. Because the initial access exploit doesn't get populated to the host until like the very end. So we'll go look at it at the router here. At that point, the initial access exploit is still populated on the task. Here we go. So here's our initial access exploit. We tell it what the code is, right, and what we want to run. And so from here, we would have the URL from that. So by looking at the host object, we'd be able to tell, okay, where did this all run? Another option is we can go look at the exploit task. So let's close all this up. And if we look at the exploit task, right, it also has the initial access exploit right here. So we could go pull the initial access exploit from the exploit task, but that's not the ideal way. The ideal way was going to be do it up in the host. Because we're not going to say, hey, go use the new exploit you just created. We're going to say, hey, go exploit this target now that we have an initial access exploit to it. All right, cool. Cool. Yeah, Drewski, it's working. It's working! Okay, cool. Let me put some notes in here real quick. So this we can pull from initial access exploits. This. I'm going to make sure I specify this is going to be from the host in here. Same thing from this. We can infer from host entry. And there we go. Infer that from host entry. This we can generate that. That's going to be a static value. That's going to be a static value. Let's see. All that's going to be the same. And then user agent, we can just leave that the same. That'll be static in here as well. All right, fine. You know what? Because it bugs me. Let's see. That's going to be static. That's going to be static. There we go. All those are going to be static values. And in fact, even these could be just static values. If we wanted to generate a new pre-shared key, we could actually leave this part off and it would go generate all this data. I think we could actually leave the build parameters blank for now. I believe that was the initial setup for it when it did that. Yeah, a little bit of the OCD, just the minor touch. Let me look at something real quick here. Let me go pull up the Mythic. Let me go pull up the code base real quick. Where's our Jupyter Docker? Here we go. Jupyter. Mythic examples. Where's our payload one? Here we go. Payloads. Sorry for the flashbang. Let me see. Yeah, because here we had very minimal build parameters in here. So, and notice how the pre-shared key is not even specified for Poseidon here. So there should be a check in there, if I remember right from talking with Cody, that if you don't specify whatever the pre-shared key is or the kill date, it should auto-configure those. Commands in here. Did he have anything in commands? No, he didn't. Let me look for something else real quick. Mythic C2 Python library. Yeah, from Papa. Let's see. Where's our documentation? I want to see if he had... Alright, it's probably just going to send me back over to Mythic, isn't it? Yeah, it is. It is. These are Jupyter notebooks. Oh, here we go. It's over in Mythic scripting in the Mythic meta. Here we go. Here's our installation. I wanted to look... Let me double check something here real quick. So we import Mythic, do a payload response, and we're going to do create payloads. See, because in the other example he had, yeah, Yeah, he didn't have a commands variable set in here. Or he did, it was an empty array. I wish Poseidon was working so we could go compare that. Anyway, all right. So a lot of this stuff we'll be able to go through and very clearly set this up using Python. So not such a big deal. Let me think what else we might want in here. The other option we've got is we can do like raw GraphQL calls to it. Let's see. Developer tricks? What does he have in here? Why is this blank? Did I make that? I don't know. Last modified 11 months ago? Maybe I did make it. I don't remember. No, because it looks like it was the same initialization time as this. All right, let me look at something real quick. There is custom queries. Here we go. So if we wanted to go through and create custom GraphQL queries and mutations, we can do that also through here, or pretty much anything else that's going to be making GraphQL calls. But GraphQL makes baby Jesus cry. And so I was hoping to avoid that, if at all possible. So like, for example, this one right here, you can look at where the operation is Operation Chimera, which is the default operation whenever it comes in. And we can go look at, hey, we want it, the ID and the name and the operator's ID and username in here. So that's a very brief example. I suck at GraphQL. I'm going to be straight up with you. So I'm hoping to avoid that as much as possible. Don't modify. No. Don't do that. Yeah, it also does have, by the way, something else if you really do like GraphQL that you can come in here is, there is this GraphQL console from Hasura in here. Admin secret? I don't know, man. Where did I make it? No, I think I gotta go look it up from the console here. I think it's Sora. There we go. Hasura's secret. Here we go. I think that's the value we need to use, if I remember correctly. Yeah, there we go. Ugh. Is there not like a dark mode for this? Ugh. My eyes. My retinas. Ugh. This is terribad. It's... We could always go pull this up in the server, but ooh. Just log out. Really? I'm surprised that Hasura doesn't have a dark mode to it. That seems like basic common courtesy. Only feds use light mode. Anyway, but if we wanted to come through and build custom GraphQL commands in here, we could come do that. So we have this to help. Honestly, I think when it comes to that though, I'll probably just have Claude Code go figure it out for me. Because I freaking hate GraphQL. Alright, let's get off that. My retinas will thank me. Alright guys, I gotta wrap it up there. I'm fading fast. We're all feds here. Actually, yes, according to chat rule number 2, everyone in chat is a fed. Alright, let's go see who we can raid out to. Who do we got that's online? Let's see, Moonwood's on, Braythorn's on. Let's see. Actually, hold on. I am forgetting a very crucial step, which is, let's go see if anybody's on InfoSec streams. Nope. I still go check it just for form, even though I know it's probably about a 5% chance anybody else is on this time of night. Let's see. Oh, you know what? Science is on. What are they doing? They're doing fun, science-y stuff. Let me see. You know what? Actually, we'll go right over to Braythorn. Because he's doing fun stuff over there. Alright, guys. Unfortunately, that is where I've got to wrap it up. Sorry to cut and run a little... Not a little early. We're basically on time. Usually I go over anyway. But I am dead. I'm dead. I'm DED dead. I gotta go get some sleep. I was tired all day. I was hoping for a nap. Didn't happen. It's alright. It was a good day. Everyone, if you're off tomorrow, I hope you enjoy your day off. Get some more rest for Crushing It mode on Tuesday. For everyone else, get ready for Crushing It mode. Instituting immediately upon waking. There is no delay to the Crushing It mode. And I hope you'll have a fantastic week. We'll have our new stream like normal on Wednesday. By Friday, I will let you know if there will be a Saturday stream. I'm waiting to see what the weather's going to be like for the race season. And I have no idea when we're going to be having it. Oh yeah, and happy birthday, Gumby!
Incoming transmission from Marano Gumby. Happy early birthday to me.
Happy birthday to Gumby.
All right. Everyone, y'all have a fantastic week. Gumby, don't go too heavy on the cake, but, you know, have a slice. Have a good one. And I hope everyone has a fantastic week coming up. Go crushing it into the week. We do not go weekly into the week. And I want y'all to remember two very important things. One, when you get into Braythorn stream, drop a bunch of happy hackers and hack the planets. And two, which is very, very important, I want you to listen very carefully, which is, I love you. Peace.